Leetcode video, and today we have construct binary tree from preorder and postorder traversal. It gives us two arrays, basically preorder and postorder, which are traversals of a tree, where preorder you actually like process this node, then check out the left side, then check out the right side. Postorder you actually process the left node side first, then the right side, then you process the current one. And it just wants us to return a binary tree, like the original tree before processing. So basically speaking, looking at these two, you kind of have to look at the gimmicks of every traversal type and see the patterns available. And then based on that, you would actually be able to like connect them together in a way. So if we look at preorder traversal, right? If we start this node, if we start this tree, sorry, and then we pop this value here, right? That's going to give us the root node. And then let's say we want to recursively go left, always. First, then we go right after. So basically, if we are here now, we're going to pop this, right? And then we do the same thing again, go left. So now we're at 4, we pop the 4, right? But then there's nothing that tells us if we're done, as in, because the 4 has no left or right nodes, right? Or we should keep going. So if I did this algorithm blindly, I would say, okay, 4, then go again left, pop the 5, but then the 5 is right here, right? So that's where this array comes in use, where we need a way to know that this is the last node, right? And frankly speaking, postorder, one of the properties of it, the 4 is always going to be the left node, the last left node. Why? Because, as I said, it actually processes the left side, then processes the root side, then processes the right side. So the first value here is always going to be the bottommost left. We can check if this value corresponds to this value. If it does, we can pop from here, and then we know this is the last one, right? So basically speaking, let's say we're here now. Right? We check, is this 4 equal to the first, it has to be the first one in postorder. Yes, then pop from postorder, right? So now we finish this side, right? So the 2 now goes to the 5 to process the 5, right? So it processes the 5, it pops it, and then it checks. Is it the first value in this array? Yes, it is. So then it pops the 5. So now we're left with this here. And then it returns to the 2. So another thing is here, when it returns to the parent, you have to know that it's going to be here as well. So this is not only for the leaf nodes. It's going to be here as well. So you have to make sure that when it returns to the parent, you also pop the parent, or it's going to ruin everything. So basically, we pop the 2 afterwards, right? So now we're left with this, and then we're processing this side right here, right? So now we go 1, 3, 6. So we're at the 6 now, right? Well, sorry, we're at the right side of the 1 because we finished the left side. So when we're at the right side, we should be at 3 here. When we're at 3 here, we pop the 3, create the node, check out the left side, pop the 6, create the node, but then check, is the 6, does the 6 start, where was I? Does the 6 start here? Yes, it does. Pop the 6 from here, right? And now we're left with 7 because we're processing the right side now on this part. But then so we process the 6, right? And then we finish the left side from the 3. We go to the right side, we pop the 7, which is the last thing. And then we check, is the 7 the first of this array? Yes, it is, right? And then we're after 3, we'll pop the parent, right? And then we'll pop the biggest parent, the 1. And then we're left with nothing here and nothing here, which is the goal. Like, for this algorithm to work, we should be left with nothing always, right? So this would work, right? But there's a small edge case that we have to take care of, which is in problems like this, basically. If we look at, oh, can I not see the, okay, sometimes, for example, let me actually bring it up to you guys. Sometimes, for example, you can, hang on. If I submit this, it's not going to run. Should break, yeah. For example, we have something like this, where it goes 3, 4, 1, 2, right? But the 2 is actually the parent of the 3, the child of the 3, not the child of the 4. But you don't. This algorithm doesn't know this. What I just explained, it doesn't know this. So the thing is, sometimes when you're doing, let's dry run again, where okay, pop the 3, and then go left, right? Pop the 4, and then go left. You have 1. Check if the 1 is the 1 here. You pop from here, right? And then what's left is 4, 2, 3 from here, right? But then it doesn't understand, so it goes. It's going to go up, and it's going to try to go right, which breaks everything. So we also need to check when we return to the root node, to the parent, if the parent matches the current, the first index of post order. That means there's no right, basically. That means I only processed left, and I processed the parent because there was no right? So I also need to pop. Hence the reason for this being here right there. So hang on. So yeah, so basically looking at the code, if there's no preorder, I return nil because we're finished anyways. We create the node by popping from preorder, right? And I'm gonna check if I'm the last value. This means the leaf node. If post order and node.value equals the first index of post order, then pop from post order, right? That means I'm the very last index, and I don't need to traverse left or right, so I return node here. Okay, and then otherwise I go node left, check out the left side, and then I check if node.value equal post order of 0. This is in between. This is to handle this case. I pop from post order, basically. So if they match, if it matches with the parent, I will pop. Otherwise, I will check out the right side, where, yeah, I will check out the right side, and I will pop it at the end. Also, I also need to pop at the end here because I either pop early or check left and pop parent again, right? Yeah, and then I return the node. So I hope I explained this as much as I could. If you have any questions, be sure to link them in the comments. Thank you for watching. See you in the next one.